Hi everyone, this is David Ngo. Today I want to share with you a new topic called integration. That means this is the reverse of the differentiation, yeah, or the derivative. Last time we talked about the derivative or different name called differentiation. So integration is the reverse. We're going to go through this one by one. Okay, so talk about also integration, also called antiderivative too. This is the opposite derivative, so-called antiderivative. Right, so they work out about error and accumulation. You remember when we talk about derivative, we're talking about the changes, right? We go to right. All right, we're learning objective. What you will be able to do is understand the concept. We see integration as the reverse process of differentiation, recovering a function from its right of chain. Right? Remember, we talk about differentiation is right of chain. Then we got read and yield notation. We interpret that this is the cycle iteration. Right? So we work out the from A to B iteration, work out the accumulative area or whatever from A to B. So we connect them to the antiderivative and area. I mean, we talk about integration and area, right? We apply the core rule, use the power rule for integrals and the fundamental theorem of calculus to evaluate integral. And then we solve real problem. We compute total accumulation, distance, revenue, volume from a right function. So we're running the derivative in reverse, right? Called integration. A derivative tells you a rate of change, how fast something is moving right now. Talk about derivative, right? Integration asks the opposite question. If I know the rate of every instant, what's the total amount of build? Think of a car speed, a speedo, right? Pedometer. It shows speed, a derivative of a position. At each moment, interaction adapt to those speed over time to recover the total distance travel. So look at speed interaction. We got distance travel here. It's adding the all that finish literally one line there. Every speed change it, but the rate of change is a little bit change all the time. But we make it to become the area. Talk about from speed into right distance travel. So each strip equal to a tiny amount added. So the integral sum them all integral sum add them all up. The two sides of the same coin, right? The derivative is slope of a point. Remember, we showed this parabola. This is the slope. Integral is area under the curve. This is the area under the curve here. If you want to work area from point A to point B, this could be the area you will we work it out, right? So this is A and B. That's what we're going to call later on, right? From one point to the other point. So the derivative is slope of tangent at the line of point. Integral the area accumulate under the curve. So that's easy to understand now. In indefinite and definite integral way. Indefinite integral, I'm going to take the integral of the function of fx. That will be the result of the big X plus c. C is this constant. Fx is an antiderivative of small fx, right? Meaning if you take derivative of this one, going to give you the other one. If you take derivative of big fx, going to give you small fx, right? So C, the constant of integration. We call a derivative of any constant is zero. Right? Derivative of a constant is zero. So in finally, many functions share the same derivative. Right? If you plus 5 plus 6 plus 7, you end up the same. Right? The same result because constant. When you take derivative of the constant will be zero. Right? So definitely integral, like we will talk about AB, right? So from A to B, we'll talk when we work out the area from A to B. Of this function will be the derivative integration upon B minus in the integral upon B. Remember, this is very important, right? Integral upon B, take away integral at upon A. So A and B are the lower and upper limit of integration. The result is a single number. The next side we call side area between fx and the exit from x equal A to x equal B. We got a side area. All right, side area might be got minus. We're going to talk about got negative, positive side area. If we got a geometric area, we always positive. All right. So the fundamental theorem and core rule, right? Fundamental theorem of calculus. If f is the antiderivative of f, then we take this integral of a to b from fx dx we express like a, right? This is formula, right? This is That means take integral of the function at point B, take away integral of function at point B. Okay. So everyday integral rule number one with power rule. But power rule the formula is uh, if you remember this one, this take integral x dx it will be this could be the formula and x to the power n plus 1 divided by n plus 1 plus c. For example, here, very easy to see. If we take integration of x to the power 3, going to give you x to the power 4 divided by 4 plus c. This is called the power rule. Next one, constant multiple, like what k times a function of f(x), we take integration, we can take k out. For example, we take the integration 5x dx equal 5 times x squared and 2. You see, x will become x squared and 2, and number 5 will take it outside, plus c. The sum rule, if you got two functions, sum of the two functions, then we split it up. Interaction of function fx plus function gx, the same in interaction of function fx, then interaction of function gx. For example, here, so easy to understand, right? So x squared, interaction of x squared plus 3x. This is a function here. That means you got our first one here, interaction first one part, but interaction the second part, but only plus one c, right? Make sure all one c, one constant. Not because there are two functions, plus two c, only one c. Okay, the constant here, we know that we'll talk about the interaction of kdx will be kx plus c. For example, interaction of 7dx, that means 7x plus c. Okay, that's a fundamental theorem and core rule. Next one, integral of special function. This is a very difficult one, right? Beyond polynomial, so the power rule handle x to the power n. But exponential, logarithmic, and trigonometric function is need their own integral formula. Every one of them is the reverse of a derivative. You already know. We already talked about derivative in the last lesson, right? So look, exponential, logarithm, and logarithmic, right? And trigonometric integral. You look at exponential here. If you take integration of e to the power x dx equal ax plus c, there's no change. Because we take the derivative, there's no change, right? I'm going to integration of a to the power x will be a to the power x divided by log a. So for example, you got a 3 to the power of x, come here 3x divided by log 3 plus c. And then look by log, right? Logarithmic, right? That means the ratio 1 on x will be log x. But don't forget this, it will be the absolute value because we talk about positive only, right? Log positive. And same idea, when I got example 2 on x dx, so got 2 log x plus c. Trigonometric, because sine x dx is minus cos x plus c, right? So take our integration of cos x dx will be sine plus c. Okay, so if the example cos x squared dx, we got tan x plus c. So this all we remember by hand, because this sort of, when you learn it, we remember all the formula. Inverse geometry, that's a difficult one, right? Inverse of 1 on square root of 1 minus x squared x will be arcsin, right? Plus c. So that's the example. We'll give you the arctan plus c. This is a very complicated one. The reverse. I call inverse trigonometry. Right, the 4 for harder integral, some difficult integral that the tool would normally use with substitution. Because substitution you set u with a gx to turn up a composite function into a simple one. Then rewrite the whole integral in terms of u before integrating. Right? So when you look at interaction by part, build on the product rule. For example, the product rule here, UV. Interaction ODV or UV minus interaction VDU. Useful whenever a product of the two functions won't simplify any other way. So what do you do rule? Partial fraction. Break a complicated rational function into a sum of similar fraction, which can be integrated directly. And then you give a trigonometric substitution. Replace expression like this square root a square minus x square or a square plus x square or this one with a strict trigonomic identity to turn a stubborn root into something integrable, right? So I'm going to give some example already because this is the harder one. For example, right? For example, substitution. Take in the rise of 2x squared plus 1 to power 3, right? So we got to choose u. The technique, let's u equal the inside here. Let u equal x squared plus 1. So du, you take du 2x dx, right? We know that we take the derivative. That matches the 2x already. Matching the 2x already here. So next to the bracket, we write in terms of u. So instead of integration of d, we become integration of u3 du, right? So you can see that from here to here, that's very critical. So you understand that, right? U3, because this is U, so the power here is U3. Or the 2x dx is du, right? We said du equal 2x dx, right? So this from this function we write to make it simpler here. So in the right and substitution back, so we'll take the derivative here. So u4 if 4, from here, the power rule, just learn power rule before. So u4 divided by 4 plus c. So we put on reply u x squared plus 1 to power 4 divided 4 is the final answer. So substitution turn a tangled composite function into a simple power rule problem. The key is spotting the derivative already hiding inside the interval. All right, that's the trick. So we got to remember this, right? Substitution. This is the function how you end up here. Right, and technique in action integrated by part. We're solving integration x times e to the power x dx. So choose u and dv. So let u equal x. Dv in this part here. So got a u dv equal ex dx. So du equal dx, right? Check. We gotta make sure I understand that. And du equal dx and v equal e to power x. So pick u to be the factor that gets simpler when differentiated. We gotta think about that. So let's apply the formula rule. We remember I talked about before. Take the integration of u dv, cái uv minus integration v du. Substitute in there. We got u. We got u equal x, right? V, we got v, where is v? V ex. You see that? V equal ex. We substitute x here. X uv, right? Take away integration of v du. Look at v. Where is v? We got v up here. V du, that means dx. Du, that means dx, right? So that's simpler form. Now from here, we fix one up as well. So we got integration the remainder. We got also integration of the whole function here, right? We got this one here, the pi integration this function here. Look at this one here. That means we rewrite here. So integrate ax, that means ax plus c. So the answer will be e to x times ax minus 8x plus c. All right. So from this step to this step, you can see very clear. Okay. So integration by part trace one integral for an easy one. Here, a product of two functions collapse into a single exponential term. Okay, so that's the result of integration of the function of this function will be this is the end result. All right, next one. So take action with partial fraction. This is a very strange, interesting one. Huh? It's quite complicated. We're going to go too slowly, right? We're solving the integration on 1 on x squared plus 1, right? Divided by x squared minus 1 dx. So the factor and split one, this one from x, if you remember from this one, we're going to split the one now, right? X minus 1 plus, and x plus 1 give you the. So we write 1x equal a on x times b. We just split the one here, u a, then we try to find out a and b. From there, we take integration, right? So solve for a and b, you clearing denomination. Right, the denominator, we got 1 equal a. This is the value of 1. Because if you common denominator, you got a common denominator. Setting x equal 1, give a equal half. You just say because you eliminate one variable. That's why we're setting x equal 1 first. When x equal 1, that means this one equal 0, isn't it? You look at that was set equal 1. So we give a. Now you're clearing the norm. You got x equal 1, so you look at it easier to see. X equal 1, this part disappear, right? Okay, so I equal x equal 1, that means I equal 1 plus 1, 2, that means I equal half, isn't I equal half here. If you put x equal minus 1, that's the power equal 0. So we got b equal minus 1 and 2. Right, that's straightforward, right? You see, so one you got a and b, we substitute there. So interaction of this function, right? Become this one become the interaction of half of this one half. We're substituting it, right? Substituting this one already become half a log and minus half a log x plus 1, right? So this log here. But we're using absolute value because they are positive, right? Look at the positive area. That's why they are log a positive, not negative, okay? So the partial fraction break one high rational integral into several easy log integral. The harder part is to finding a and b, split up find a and b. Okay, this is how it's the hard part. So got to practice many times to get us experience. Okay, so talk about this next one with trigonometric substitution, right? You're solving this is square root 9 minus x squared here. We choose the substitution, you know, x equal 3 sine theta. We will work out, try to take the side, and so dx equal 3 cos theta. This one here is very, very tricky, right? Because you know 3, 9 is 3, take a square root 3, also 3. So square root 9 minus x squared equals square root 9 minus 9 sin square theta. When you substitute in there, x squared, put x at 3 squared, you got all the square here, right? And got sine square here, you got so from this formula give you 3 cos theta, right? Because you don't know, take 9L will become 3, so it's take square root L now. 1 minus sine square inside left, that means equal cos square, right? You remember when you're learning 1 square, sine square plus cos square equal 1. That was substitute and you got this answer. So you got 3 cos theta. So rewrite in terms of theta. So this equal to 3 cos theta theta divided by 3 cos theta. So the integration equal theta. You just cancel. So got the integration theta. So integration substitute back. You got the integration theta plus c, right? When you got the integration equal arc in x on 3, you reply back in here as x on 3 plus c. They call action. You got to go to a formula. That's very the reverse icon. We call inverse, right? Inverse. So the trick identity cancel the square root cleanly worth recognizing any time you got a square and x square show up in an integral. So this is a complicated one, but when you get used to it, then you understand. Okay, because when you try to split it up, set it up, let something that you can sort it out. Okay, this is the difficult one. So from we look at from rectangle to the exact area here, right? A number of rectangle and increase, they are not a combined area converge to exact value at the definite definite interval. You look at this one, you got a rectangle, just all of the area, the change is little area there. When you make it very small, the 10 you know, the number small change like that. When you go to infinity, that means exactly got in third, they go exactly right result when you do the iteration. So we look at the whole area here. So we got the right result here. Okay, step by step, the work example, I gotta do all the examples so that this one you gotta practice a lot of times so we remember, right? We take iteration from 1 to 3, now x equal 1 to x equal 3, a equal 1, b equal 2, 3, we want to find the area of this curve from a to 1, right? This curve here. So find the entry, once you got this function, we take the interaction of these, right? So x3, this one just split to x3, x2, x squared plus c. Apply the fundamental theorem. That means f3 substitute f3 evaluate f3 now from this function here evaluate f this integration of function with x equal 3 minus integration of function with x equal 1. So from here you substitute now you got the result, right? Plug in the upper limit x equal 3 here, then got x equal 3 here, right? And I got partner x equal 1. So you got a whole area. This is the answer. Got from 1 to 3. Okay. So the area 18. Okay. So I go through a step. Think it real slowly. Then you just practicing. Then you can see the result. Make sure the theorem here, right? The theorem here. Okay, F3 comma and F1 now you substitute 9 plus 9 equal the end result. Okay. This one and putting lower limit x1, so x1 here substitute. So you got 1, 2, 3. It's like the result. So 16. This is the error here. 16.69. Okay, because you got F3 minus F1. Okay, so the area under after x squared plus 2x between x equal 1 and x equal 3 equal to 50 of 3. That means 16.67 here, square unit. Okay, so the 6 step to go. When you do it, go to for a 6 step, right? Okay, let me go back the previous one. You change it. Step 1, you find the derivative. You apply the fundamental theorem, right? And then you put the F3. You substitute, you put the F3 in first. So that means x equal 3. You put them all. You got the result 18. And then go to the next one. Go to the next one. You got plug in the lower limit f1 x equal 1. So we got x substitute x1. So substitute F3 minus F1 here give you 53. So that is the result. All right, that on a sample. When interaction show up, you got look at you got in physics, so in the right velocity. Then for example, you get a total distance travel. You work through on the next slide. You got to see that economic. You interact. We're gonna give some example about it. Indirect marginal cost, right? So 50 to find the total production cost. Work through the two sides. Right on. Engineering with tank filling like right? Accumulate, we work it out. Medicine, the drug with blood concentration, right? So check, this is application in real life, okay? Listen from the example, or talk about velocity, right? Set up the intro a car velocity VT20 T meter or mile, whatever, meter per second. Find the distance travel from t equals 0 to t equals 5, t equals 0. Find the distance travel. We know the velocity just increasing very fast, right? But we want to find the area. So we find interaction 0 to 5, 20t dt. So find the antiderivative and take the interaction of 20t dt equal 10t squared plus c, right? Remember? 10t squared. So st equal 10t squared. So apply the limit and compute, right? S5, S0 minus S5, right? So S5 minus S0. So you apply limit to compute S5 minus S0. So substitute 5 in here. So the total, the answer is 250. So the car travel 200 meters in the first 5 seconds. Right? You understand that that's an interpretation here. That means the car travel 250 meters in the first 5 seconds from 0 to 5. Right? First 5 seconds, interaction turn a constant changing speed into one total distance. That's a critical, right? Turn a constant changing speed into one total distance. Right, next one, the total cost for marginal cost function. We set up in a factory marginal cost, a MCX equals 50 plus 2x dollar per unit. We find the total cost of producing first 100 units. That means we find the interaction of C equals 0 to 100 of this function, that marginal cost function, right? So find the antiderivative, we got the one, we understand how to 50x plus x. So Cx equals 50x plus x squared. We substitute there, apply the limit and compute, right? That means C100 minus C0, right? From 0 to 100. So you got to substitute in there, got a number here minus 0, so that 15,000 is the answer. So produce first 100 unit cost $15,000 in total. So interaction accumulated a changing marginal cost into one total figure, right? One total figure 15,000. All right. Now, practical question. Try yourself, right? Try yourself. Try it yourself. Very important. Work to interrupt before checking the answer. Column. Everyone apply a rule from this lesson. No calculator needed. You buy on it. Well, the question here, you hint how to add up. You got answer here. This is very simple. Okay. Interaction. If you don't feel time, then you remember. Okay. Bringing it all together. Interaction is the reverse of differentiation. It recovers function from its right of chain. The indefinite integral, right, actually give a family of antiderivative fx plus c. The definite interval A to B. This from X A to B. After give a number, the net area under Fx from A to B. The, the fundamental theorem calculate linked to the technical derivative Fi, Fb minus Fi. Interaction power real calculation, distance, revenue, volume, and total exposure. Right. We're going to later we're going to look at the program, the Python program to work them all out first very quickly, right? This interaction got to some. If you talk about geometric area, then will be a different outcome. Geometric area always positive. So if they go to the x y equals 0, right? Then you sorry when I go to the x equals 0, then the area will be two part add up together. We'll explain later when we run the program. So this is important. The key takeaway. These are key takeaway when you learn about interaction. Okay, now we are going to go to the Python program, right? We go to the. It's very critical to go to the Python program to see how it works out, right? To see how it works out. This is Python program that I got here now. We're going to run it one through. This requires a little bit complicated because this is the F, the application, right? Python, this is to do, I call interrupt F. They got consider interrupt POI. You got an engine to run. You got input guide show you how to put input. Interrupt how to show, draw the graph. Interrupt point analysis. What's got the result. This is instruction, read me instruction because it's every require what you do. And I also put in the stream lead app as well. So you can play with that. Right? You can use when you click on a link on your iPhone or laptop, whatever, you click on a link, then you can play with this pro with the app, right? Put in your own input in it, and then they will sort out for you in no time, very quick, right? And utility will explain all this for you too. Okay, let me run it one first, then we come back. Then we come back to go briefly go through the program, right? All the program is quite interesting, right? Because there's a put them all in little block right there, so easy to fix. Let me run it. Right, this is the guy here. First part, when you run it, see the result. This is a professor into analyzer, right? We call it, I got medical expression and meaning. When you do the computer reading sign differently, right? For example, x square, well, this is x square, right? But when you enter that, you got enter like this because the computer can read it one only x star star 2, that means x square. X cube will be x star star 3, right? To power 3, x to power 3, good typing. When type 3 times x, you must get 3 times x, this one time here, the star here. 3 times x squared got to 3 times x star 2. You see that this pi x squared, first one is 3 times x squared. Okay, the polynomial, same thing. You put in this, if sine x, you put a sine x, cos all right, x sine x. This is x times sine got times x star sine x. This one very critical. You got to input correct, e to power x, or you have to type in, you got to put e x speed x. E to power 2x, right? E power 2x. A2 times x, right? A2 times x exponential here. A raised to 2x, you see that? A raised to 2x, okay? Log. All this is the guide for you to put in. Make sure you got to do it right. Otherwise, you don't have the answer. All this to explain is to explain for you what to do. Now I run the first function. We have a look first, right? X to power 2 x to power 3, for example, right? I want to plus x to power 2, right? Plus 7, for example. Just for example, I run the function, I give you, I'm gonna do a 3 level 1, 2, 3. I want to do 3 at type 3, I want 2 type 2. I type 3. Now I got the graph will limit me, I just signal change, because the graph, the big side, I can do it, right? 6 minus 6, 0. And 2, there are the definite, right? The definite interval, the area over 2 interval. Yes, I want to do it now. I want to start from x equal minus 1, for example, right? To x equals 7, for example, right? Put it in, give the result in no time. So the graph takes 0.276 seconds. This is the area here. The work out I explained to you. Let me see the ask if I'm gonna save the file. No, I don't want to save it because you can save it if you want to do it, right? And I'll give you the chart here. This is the result here. It is the end result here. Okay, you see that? All this the end result. You can say antiderivative or derivative. This is the formula how to work out step by step. Okay, all this doing all step by step. You can this is the area here, highlight the area here. This is a highlight area. That's what we're looking for, right? So the area result is one give you the area result. Right now, notice that you got side area, side area. You got same, but you got this in this case geometric area. They are the same because they are positive. But sometimes you run different one. I'll show you next example. Then you're gonna see the difference, right? So these are the special point we learned it already. The local maximum inflection point without it and all the explanation, right? Without this is all accumulated area and so on. So this now I want to run this. I want to see how to do step by step. We're clicking close here. You see, I explain you in the terminal here. Show you the answer here. You see this how to do you see that I just enter here the answer here. I just enter is the function, right? Calculate the function, work out in the formula here you got to use. Step by step I show you before, so just reply your step one, step two. Explain very clearly for you to understand. So how you split, you use the method, all this one, and step come down here, step three, step four, you add in your verification. Right? You can verify when you take derivative, then you end up the result that you call, right? You check it that you verify. So y plus c require we explain because it's a constant. So antiderivative all this you got f right here, f2 the level 2, f level 3. Right, the three level. So our style error is a style error in this case, and geometric error identical because they are all positive. Right? So if one negative, then you can see the different result. Detail working your style error here, you have to work the style error here. Geometric error working, how to work at geometric. Geometric in this case they are the same. But if they're not same because they're all positive. So that's why you end up the same answer in a way, right? Geometric area always non-negative because every region is at the positive. Right, so special one of fx it is. Okay. So this is one then, right? I'm gonna run something else, right? I'm gonna try. I want to run another function, for example, to sine x. I want to do sine x. You can do a lot of complicated one, very hard one, but I don't want to take it to I got take 3. Right? I take 2 only. So make it easier. Take 2. Still the same thing. The rep line is so big. I got interval. Yes, I want to interval. This one very tricky. Here one I will show you. If I got minus 2 from minus 2 to plus 2. So what happened? I want to write x equal minus 2 to x equal 2 because they will go cross the x axis, right? You see the result here. I'm going to explain later on. So if the graph say the graph no, I don't want to do it. So we're going to see the chart result here. Interesting here now. Iteration. You look at this on your file iteration, right? See that's the area here. You see highlight area here. I say my from here minus 2 plus we take the iteration minus 2 to plus 2. You see that? You go to 0, 1 here. If you add a 1 here, you got the side area will end up 0. You see that side area end up 0? Got a negative and positive. But the geometric area double up, right? Geometric is this part plus this part positive. So that's why I got to understand that we're going to choose step by step local minimum. That's all normal, all is normal. Right, this one just take it in derivative, make sure how to do it. I close the one up, show you step by step here. Okay. Now we start step by step here. See, we put a function here, f(x) sine x. So step by step antiderivative, fx equals sine x. So it's standard function. So take derivative, give it minus cos x. From here, final answer minus cos x plus c. You verify, you take derivative verification, right? See the same. We explain the c the constant. And how interesting, look at it here. fx minus x. So your second repeat derivative like that. Side area, you got interaction minus 2 equals 0. And geometric area, you got 2 you got above. Right, the detail working, how to work in the side area in the right minus 2 to 2. Again, step 1, you find antiderivative. Step 2, right, so you got this is cancel out. So that f2 minus f minus 2, so cancel out equals 0. So concluding the positive and negative contribution cancel exactly. So geometric area, then you got to use the positive side. When you talk about geometric, the function got to be absolute value. So you find the x-intercept at x is 0. So you split them up. You split interval minus 2 to 0 from 0 to 2. So that was 2 parts. That's why you add up. You see the area up, right? That's why you got the answer. So conclusion, a geometric area is always non-negative because every region is added positively. right? So all this is the local point in reflection and so on. Okay, see that done very quick, 0.17 second, not even not 1/10 of second to get it done so quick. You can play with this, right? You can put all the function, very difficult function, uh, logarithm, look on log on whatever. That's very complicated. You can put them all in. They will provide you with the good result. Okay, I don't want to take it too long your time, so I think that's enough. So I don't want to do it anymore. Add another function. I said no, I don't want to do it. Right, forget it. Okay, so goodbye. Just leave it like that. This is a very powerful app that you can use. This. When you go to Streamline, I can show you how to go to Streamline very soon, right? Just have a little break. Now we want briefly to go through, go through all this code, right? This Python language, right? This is Python language, okay? So this is, that for a long time, right? We talk about the Python language for a while now. So for this f called integral f here, right? I said that perfectly calculate the antiderivative or we call antiderivative. You know that we talk about in, integral, right? Integral that means antiderivative, right? Indefinite integral, right? And definite integral, right? So a medical function we're using Python, right? Using Python to do that, okay? So when you are talking about Python, they for this app to work, we got so many sections here. The one the intro app is the main one. This is another component called the engine, right? Intro engine and intro input guide. You can see the guide already. Intro plotting provide the graphical result. Intro plot analysis analyze the result, right? This is really the guide how to use it. This one a Streamlit. This I put it Streamlit in here. And this one is also used to I hook it into via GitHub. From GitHub we go to Streamlit Cloud, go to Streamlit Clouds, all right? From there you can use your iPhone or your laptop, your computer, and you play with the app free, and you can copy whatever you like. Utility just only show you how to use it, right? Okay. So this program here, just really go through it because it's quite a long program. That's why I break up so many different parts. These are integral after so the way working here, you import it, right? All this importation. You can copy that, right? You can copy all this your wishes, okay, and you can play with that. I just show you do slowly, so that you can see the structure because all the import we are from this one because they got so different things over you. The one you said they import all the function in here in the main one to run, okay. So they import integral engine. You see the integral engine here? Make sure the name is correct, right? From integral engine, you import all the function in there, right? From input guide, you import. So from integral plotting, you import, right? From integral point analysis, you import all the function in there so they can use. From utility, you import all this, utility, all the form and so on. You got import them. That's the structure. Okay, so you look at after the structure, you see this is the function, after mean the function of this. From there, you got function. You got put our answer for all the step. I think you've been through that for a long time now. Well, you're gonna go through all this one, and you copy and you analyze it, right? Copy and run it. Okay, this is the plot, this is the return, and from there you see that auto white by slow here with this is the function to print the result. So they imported you all the function. So with none that the result if or the if for is all this loop here to work, right? It's a if else, you see that's quite long, very long. Okay. When you are print the result of special point, or print the special point, how to print how many distinct special point, and then you talk about some extreme fx and so on, right? In the final inflection point. Then you print now here, you print again, you print what you want the processing time, how much is very quick time the processing. Then the function from function add you to the input, you put the input in, also input you should put in. All right. And when you finish, you put exit or quick, whatever you want to do, right? I said yes or no, depends. So this is a whole lot code that we got put in. You see that from X rank, and you see how to draw the rep. Now left rep limit 0.6, 6.6 where they coming from, right? And You got all this outflow flow return. You run the session. When you run the session, you got a time performance. See all the F here, side path. So this is the main function. When you run Python all the already main function, got all the function that, and this is the main function, right? There you go. That only one app here. It's got interroll app. Now you look at interroll engine, right? Well, look at interroll engine. What in there? Interroll engine too, yeah. The calculation did more calculate indefinite or definite interval, right? So that in the future, look at our import. This is the program itself, but they got a lot of function in here, right? So this is the second part. You can see this program is still quite long though. You see all the special thing, the way you display the special function now. You also this is very difficult function, right? This is all the difficult one. You rarely see them, but additionally, this is for those who got that sort of knowledge, right? This is a very advanced function, right? That you really not many people see that anyway. Okay, but you can run on this as well. Okay, all the special function. You just follow to the instruction, right? And then you can see the whole list of special function. Okay, people have to see like the audit, delta, and so on. Heavy soil, gamma, zeta. You return the text from this part. You part the function. See what sort of function we have. Right, so the error input. Now you go computer interval, how to work out interval. Now first level, second level, third level. Right, because add the constant in, or the add the constant in, and from there you look at the subscript. Okay, to subscript index. Find a real flow, singular point in interval. Got import or interval value. You got these are a lot of function in here, and this is if I interval, when you can get out the result. Sometimes you don't have no result. I should show you some kind that you cannot work out the area because they go to infinity. Right? Then you got asymptotic and so on. Asymptotic, if you remember, you're talking hyperbola, something that never made, so they never end up the result unless it converges. Otherwise, you cannot get the result. So look at geometric area, right? You got geometric area. We talked about that before, and also you got um, the side area, geometric area, and now education line. See all this online. The side, the area working line. Will explain you step by step to the audit working line. Right, single line expanded, so on. Quotient. Sometimes when you got no file, when you got no conversion, that means they not end up in the final number. Then we cannot calculate the area. That's why all this program work. And I explain to you very clear when you run it. They can give you very plenty explanation down there. All right, this is quite long. Isn't it? I see that this is called interval engine. This is a program with interval engine. Got the power of the overall app, right? It's power of the overall app. Is it an interval engine? Almost impossible to remember this line. You just need to copy and patch and make sure that you understand the basic of how to run the program. And someone may already built anyway. You can use it. Probably can use many times. Okay. Except an integral definition by power working, or the function, the partial fraction working, uh, term, or this one, and the right term. Down here, you return the five trigonometric subradical, or it down here. Just substitution working. Um, if and L if, right? Set up coefficient, if it's L if L return. So if L return this, you see that you don't have main function, or this is not main function. So it is supporting interval engine py, like dot py. This RAM see about over 1,000 line. Okay, look at the next one. The next one also input line. You see that already. This one is to understand because you see that all the symbol for you. These are from future import all day, right? You got all this on special function input guy. Show you all the guy. You may when you see the guy how to do it. All these guys will show you. like x square, you got to type in x like đấy, x cube a time like this, audit the table, they bring out the table for you, right? You see audit return table, whatever you do, right? Example function, I said audit are some function got already in there, built in the function, audit on here. You can use audit on straight in if you wish, otherwise use your own function, right? That's the alternative for you. So the table, how to do the get a table header, then got banner, how you look like when you got a map, you see that return. You consider calculate is in not the main function. That's why they are separate one guy. Then use the internal plotting. You see this a very long one too. This is function to plot the map, right? You plot all the graphical results. You got to import data typing and so on. You got TK thing, you got to use it to wrapping boxes and so on, and so on. So you see that from internal engine, you import all this, right? You said it's internal plotting. You got to import from the engine, right? And all things are there. So it can analyze from internal plot analysis. You got to import some function too. From beauty, import all the font and so on. You see that? So that's the way the program being structured so that in case something wrong, then you try to fix one block at a time. You got so many block in there. This here, you got a different block. So you can call it block interoperable one block of the main program. Okay. So like that, you see that quite a long thứ this one here. You plot the result, you end up the result. When you got the result, all it want the plotting, give you the, that was the ref and so on, the font, how big it is a canvas, okay? The font size, how you do it, want to make big or small. Okay, when you bring out the output, or it's on the, um, it's on the plotting here, right? So from plot now, you see that's still quite long. Absolutely integral part law, a panel law, how to draw law and so on. The area, you got to highlight area. Okay, so the specific point panel law, your critical point, your inflection point, and so on. This part point and wall out and label for you. All right, meaning panel explaining, right? Or the panel here. This is a internal plotting. And now got internal point analysis or analyze the result. Okay, look at this one here. Analyze result and there. Numerical root finding, special and so on. All this one here. So you see this also import. They all got separate import numpy from YouTube. YouTube here. They import all this on here, right? Or special function a lot here. You did like this special point, and there's a five special point. This when you're talking about internal point analysis, the analyze, right? As they look at for intercept, you find intercept, you know, find critical point, then you find inflection point, then you got a numerical root. You see the next one. You see a root by side change. Some then you got a root by tangent shears, and sometimes you go for the tangent being talk where tangent to the curve and so on, right? So this one you got a root by symbol so. I got root, I got not, you got root normally, you got two area, right? One positive, one negative when you go to the root, right? So side on side and so on. Look at all the class of critical point, you got that the why a local at minimum. Class of index validate root. Okay, good side value. Margin, dialect down here. Right, see a lot of function here. Look at all the matching point index. All the function is for integral point analysis, right? And now this is only document. So all the document there. We look at that here. This is Streamlit app. How you put in Streamlit? Because that's special. Because if you don't have a Streamlit app, you cannot use the Streamlit cloud to run on your mobile phone. That is special structure. That's a special structure uh, for Streamlit to work. Okay, normally our terminal won't work. Our terminal to work on all this on here. PyCharm to work on this one. We won't work on Streamlit app, right? Because Streamlit is a special design that we can upload our app onto GitHub. From GitHub, then you go to Streamlit, right? You can further you link with Streamlit. From there, you can use your iPhone, laptop, whatever to play with the app. Right, you can see the app freely up there. You can copy, download whatever you like. Okay, you see all this app here, all the code here is quite long too. You see that? There's no main function except the first one, I showed it before. For utility, the same thing. You look at utility. Utility is got already got a command style. All right, you got to import and by simply. Right? You see that how to read, make it easy to read, and how to utility. It is script message makes you convert to human readable, to script because something that so many star there, convert a different one, right? To actual level 2, actual Q, and so on. That's so easy to read, human readable one. The superscript or superscript, right? It's on the cosmetic, right? So just see that, yeah, so we can print. But the computer, otherwise, the way the computer print it out in a way that we can read easily. Okay, full script, like subscript, how to bring it out. Coefficient. Okay, that's utility, right? Called util.py. How to present it, form, derivatives. Yeah, that one over there. Yeah, how to remember this, right? When you compile it, you find them and so on. Very hard. Replacing this, rep square root, radian, talk about radian, human math. So you see that for x squared. From this one to this one, you call human readable. From this one to the one, human readable. Otherwise, very hard to read, right? All these, right? Uh, I try to do it so they present it right away. Okay, that's still quite complicated. All right, that's all the text here. You can copy, all right, you can copy and play with that if you want to. All this very special function, very difficult one. People hardly see that, right? I just put them all in case you want to play with that, right? Like just our function, what for? That's very something that you will rarely see that. Unless you are special, let you learn in special area, right? Mm. Set evaluation as integer as flow. Yes or no when you think that. That's it. Utility. Under the two finally, Warrior just explain to you how to read that at all. A requirement to make sure they run in the app, right? When you put in the app, you might have such a requirement so people understand. Okay, so this is the Python script. Right? You can see that very long if you combine them together. One program too big, lost track. And when you got something wrong, how to fix, or just split it up like that. So easy to fix when you got a testing program and not working, or working or not, and you can fix up easily, right? Easy. Okay. So I think that's about it, right? I think that's about it for our now. And now we continue to look at this software I call the app, right? The application work out work on the integration, right? This is a link. I just highlighted this is the link, right? The link that I provided you in my channel. In my video, when you go to description, there's this link will be down there under my description. You can click on this link using your iPhone, and it will take you straight away into this in this screen, right? Take you straight. But sometimes if you can't see too, I see the sign already on your screen. Right, on your mobile phone screen, you can click on it to see different page. This one page, this is the one page, right? So if you go see that you can put your function here. I got some function already. I got input guy here. One you want to know, you click on input guy to show you down here order guy. I already explained to you before, how to type it one in, right? How to type x squared. I mean x squared, right? Order is on here. There's an input guy down here on one little page. Okay, and you can make the pie bigger if you want to, right? But I just want to show you here. And then you can see that one here. You got a lot of function. A lot of function I already been previewing. Now I'll give you an example. Because put out some function down here. Is it a symbol and function example to try? You can click on here and then you can use an example in here. But anyway, I'm gonna do that one. We do our own by on different function. Try different one. As you log, I put a log x, for example. I want to try log x, right? So my x times log x might be better to make it a bit more complicated here. X right? I want to do a function x times log x integration. Put an enter here. The repeated derivative or you got 1, 2, or 3. You can do up to 3 that level, even 3 more down to 3. So give you 3 level, right? Graphical starting this is the now change it because this is look reasonable. You change it, it might be a bit harder to read. And I got lower limit, when I work a lower limit minus 2 to 2, or I can change that number. I said, start from 0, from 1 to 2. For example, from 1 to 2, I put out 1. Right? Start from 1 to 2. So lower limit is 1, upper limit is 2. Right? We show the detail working. Got to click Analyze Interaction. Give you a result very quickly. You see that result very fast. Computer is amazing. So give you the this is the result. So function of the result first. I say I got the function fx x log x, right? We input in x log x. So the fx first thing I give you the answer. Level 2 give you the answer. Level 3 give you the 3 answer. Okay. So in the row, I said I will put from 1 to 2, give you error 1 to 2, right? So give the geometric error same as sine error because they both them are positive, so they're identical, right? Both are positive, okay? So that's why identical. So you look at all this, the result come out very quick, and then you got a all special point, local minimum and so on. So you got to treat all the functions and show to you very clear. This is step by step working that I explain to you how to end up how to work out step by step using paperwork, right? So you define the right UDV, UV minus this one here integration by part. From there you step 1, you got du equals this, dv, and then you got step 2, you calculate the du, right? From u here du dot 1 right? Dv uv you take integration of the log x, right? Then you got the answer. Step 3 substitute there. Right, that you got iteration like that. From there, you got step 4, evaluate the remaining intervals. You got all these. Okay. So step 5, you substitute the value in the formula and simplify. That's step 5. Okay. Step 6, you add the constant interval. One step by step. So final answer will be this is the final answer. So all the can be verification using the one you take derivative. You come back the same. You find out the result. So C required. So the side area here, working side area, the side area can be negative, positive, right? So the side area here, the interaction of 1 to the function. So step 1, you find fx, right? And then you substitute, you find step 2, you apply functional theorem calculus. You got f2 minus f1 here. So you got this one minus subtract. So you got this area, right? You noted that you got a sign minus and minus, right? So you got 0.63, right? So conclusion, the side result in positive. So the area of burn x-axis is right there, right? The burn x-axis, you see the chart I showed you before. Anyway, I work out geometric area, then you got different one. You got split them into 5 x in somewhere, right? Is there any intersection when you look at the chart? In this case, you can see what happened. In this case, x1 to the x does not change sign on the interval. There is no interior root, right? So interior root, so no root. So fx greater 0 on interval. So they're the same. So all the areas should be right. They give you the same answer, right? Because geometric area always non-negative because every region is added positively, right? So that's why you always absolute number. We got to look at geometric, right? So this one, the total area answer very clear. Is 0.636294, right? That's the area that we want to work on. Okay, different 1 to 2. You can see this one here, this area. All this step by step working all out. All right, that's good for you to play with this, right? So play with your iPhone. The more you play, the more you can learn, and you can be expert on this, right? Because you know, need to practice a bit more. For the different function, and this is step is a free. Play I many times you like I you got the right link in there. This link is repeated. This link I place it in my description under the video. When you're watching the video, right, there will be a description with this link. Okay, I think that's enough. Thank you for your time. I will talk to you next time.